Hi everybody, Ms. Lee here. Today we're talking about the chain rule. The chain rule is for when you're taking the derivative of a function that has a function within a function. Do you guys remember what that's called? That's called a composite function. Exactly. So this is specifically for when you're taking the derivative of a function within a function. All right, and so when we're doing that, what that looks like is you're taking the derivative of something that looks like f of g of x. Okay, so the g of x is your inside function. And so when you're taking the derivative of something like this, you leave the inside function as is, and then you multiply by the derivative of the inside function. So what that looks like is f prime of g of x. So meaning that you take the derivative of the outside function and then you leave the inside function as is, and then you multiply by the derivative of that inside function, so times g prime of x. And this is the chain rule. Okay, so let's go ahead and do an example of that. Okay, so we're going to find the derivative of f of x equals sine of x to the fourth plus 3. And so in this, when you see something like this, you see that the operation that's going on is going to be a composite operation. So it's not actually an operation. There's no multiplication going on here, meaning that this isn't like sine times x to the fourth plus 3. Sine doesn't stand alone. It's going to be sine of x to the fourth plus 3, meaning that you're taking the sine of this stuff that's on the inside. So there's an inside function there. And so what I do is I kind of think of this as like, okay, like if I can cover this up, this is our inside function. So our outside function is sine. And so according to our rule here, you're going to want to take the derivative of sine and then leave the inside function as is. So we take the derivative of sine, and that'll be cosine of, and then you leave the inside function, right? So g of x, that's the original function. So you leave it as is. So x to the fourth plus 3. And if you ever leave some inside function as is, you have to multiply by the derivative of it. So times, and then the derivative of g of x, so the derivative of x to the fourth plus 3. Well, the derivative of x to the fourth is 4x to the power of 4 minus 1, because you subtract 1 from the power. And then plus the derivative of 3. What's the derivative of 3? Well, that would be 0. Okay, and so then f prime of x equals cosine of x to the fourth plus 3, and then times 4x cubed. Okay, so just to highlight kind of accordingly, I just want you guys to notice that the x to the fourth plus 3 is this original inside right there. And then we're multiplying by the derivative of it. So this is the derivative of. Okay. Okay, we're just going to go ahead and do one more. So we'll go ahead and write the equation of the line tangent to y equals 50 cosine of 2x at x equals pi over 8. So for the equation of the tangent line, remember you need two things. That would be the point and the slope. And so we'll start by finding the point. And so then we'll plug in x equals pi over 8. So that's y of pi over 8 equals 50 cosine of 2 times pi over 8. Well, 2 times pi over 8, if you simplify that, that's the same as pi over 4. So this is equivalent to 50 times cosine of pi over 4. Well, what's cosine of pi over 4? That would be root 2 over 2. So this is equivalent to 50 times root 2 over 2. And so if you just simplify that a little bit, that'll be 25 times and then root 2. Okay, so the point is going to be pi over 8, comma, 25 root 2. Now we're going to find the slope. So for the slope, as you guys know, we're going to go ahead and take the derivative. And so for this derivative, we'll do y prime equals, and then there is a constant in front, so that's being multiplied. So this is a constant multiple rule. We can just carry the constant down. So the 50 stays. So we do 50. And then times, we're going to take the derivative of cosine of 2x. Well, the derivative of cosine of 2x, well, I know what the derivative of cosine is. So that 2x is going to be considered an inside function, So what's the derivative of cosine? Well, that's negative sine. Negative sine, and then we leave that inside function. So whatever I had covered up or pretended like was on the inside, that would be the 2x. We're going to go ahead and write that in. And so since I covered something up, or since I just carried the inside function, I have to multiply by the derivative of that. So the derivative of 2x is going to be 2. So we multiply by 2, and that's going to be our derivative. So we're going to do y prime of, and then we'll go ahead and plug in the x equals pi over 8. And then we carry this down. So since there was a minus sign, I'm just going to go ahead and bring that to the front. So we have minus 50 sine of 2 times pi over 8 times 2. All right, so 2 times pi over 8, as we said earlier, is the same as pi over 4. So we have y prime of pi over 8 equals negative 50 times sine of pi over 4, and then on the outside times 2. And sine of pi over 4 is root 2 over 2, so we simplify. So we have negative 50 times root 2 over 2 times 2, and you'll see that those 2's will cancel or 1 out, so they divide out to be 1 because it's the same as like 2 over 1. And so then we have y prime of pi over 8 equals negative 50 root 2. This is going to be your slope, so this is the m. Right? So let's go ahead and write the equation of the line. Okay, so again, we'll use point slope form. That's y minus y1 equals m times x minus x1. And so that would be y minus, and then y1 was right here, 25 root 2, equals m, which is negative 50 root 2, times, and then x minus x1. So x minus, and then pi over 8. All right, and so that's going to be the equation of our line tangent to y equals 50 cosine of 2x at x equals pi over 8. Okay, happy day!